Day 3 is complete. Let's go back to the Advent calendar and go to day 4. You're almost ready. Already almost 1.5 kilometers, almost a mile below the surface of the ocean. Already so deep you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards in which it appears. Numbers may not appear on all boards. If all numbers in any row or any column of a board are marked, that board wins. Okay, no diagonals, that's nice. Submarine has a bingo system to help passengers. Currently, you and the giant squid pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. So this is our sample input. Let's go add in. Oh, before I do that, let me go in and add day 3 commit. Okay. Day 4. No. Day 4 / there we go. Day 4.swift. This will be enum day 4 static func run. We'll go over to main. We will add a day 4.run. And then in resources, day 4.test. Okay, so what we can see here is the top one is comma separated list of inputs. Then we have blank lines, and then I can read 5, 5, 5. I'm pretty sure that it's always going to be 5, even in our puzzle input. Let's just double check. Yeah. Okay. So we can just assume it's 5x5. It wouldn't be hard to make this parameterized. So we pass in like read a board of this, and it will assert that it has 5 numbers across times 5 rows. So let's get some sort of bingo parser, maybe. We could start with a bingo board. And we need to be able to mark the cells inside of the board. So I'm going to call that bingo cell. We could just use integers, but then we end up with kind of primitive obsession where we're going to have a set of integers that we're tracking, but also whether those are marked or not. So here, I think this will be let value is an int, and then let marked is a bool. And I know that I'm going to have to change these, but I think that this could be done in a functional way of like, say, given this bingo cell, I could say, give me another one that is marked. And that would return, let's do init, value is an int, marked is a bool, which is initially false. And then this would say init value. Actually, I think I want that to be unnamed. So init value and marked is true. So that way I have a way to take a cell and get a new one. Let's see, that should be is marked. Okay. I don't like the song either. Okay, so now our bingo board is basically going to be an array of cells, bingo cells. And you could do two-dimensional array if you want, but I think it's nice to just say, here's row, 1, 2, 3, and then the next row is just still in the same line, and we just have a function to convert x, y coordinates into the actual array index. Okay, and then we're going to have a bingo parser, game parser. I don't know. And this needs to return an array of boards. So this will be static func parse. We're going to get some input, which will be the string. And this needs to return an array of numbers that we're going to draw, as well as an array of bingo boards. So for now, we can say empty, empty. All right, let's let input equals read file, and this will be day4.test. Then we will and we can destructure the tuple here. This will be let numbers and boards equals bingo game parser dot parse input, and let's print out the numbers. And then print out the boards. Okay. Okay, so we know that the first line is an array of integers. So we can get input.lines. Input.lines, and it's kind of what I want to read the line and then advance. Like kind of continually eating from this. So it's kind of like if I do lines.drop first, I don't think that does what I want. This returns a sequence, drops n elements before possibly returning the first available element. Consumes and drops. Is that what I want to do? Not on publishers, on a collection. I have to say, it's kind of hard to find stuff that exists on like many types. Any collection. Drop first. Yeah, because it doesn't have it doesn't have my documentation on that. Okay, let me open a playground real quick. It's one thing I think would be kind of nice to do in. I've seen people do this with Emacs, where it'd be nice if I could say like let x equal foo or whatever, and highlight some lines, and then execute some command, and it would run that in a Swift compiler, and then like output. Oh, this is 5 or whatever. I think that would be kind of nice to be able to like kind of stay in here, but be able to like execute some code real quick. Okay. So if I have lines as a string array of hey there, and then a blank line, and then other stuff. And I say lines.drop first. This let print x and then print lines. So the x gives me everything else except for the first one. That's not what I want. I wanted to mutate it. Removes and return. Oh, removes first. Okay, so it's not drop first, it's remove first. All right, so we could say lines.remove first gives me a single string, and on that string I want to split with the separator of comma, and I want to compact map this, which gives me the number, and I can turn that into, it gives me sort of a substring, and I need to turn that into a string so I can pass it into an int. This is a failable initializer, so compact map will get rid of them, and so these become my numbers. Okay, let's build. What did I miss here? Line expected to, oh, I need a return statement. Okay, build, we're good there. And let's run it so we can see that we got our numbers. Okay, we're good there. Now let's parse the boards. So we can say board size is 5, and that's a constant now. And so we need an array of boards. And can I take, there's no like remove first n number of lines. No. Because I basically just want to continue it's like I want to take the next n numbers. I suppose I could turn that into a publisher, and then I have take, I think. It's not take here, it's prefix maybe. But I don't want to do that. If I do lines.forEach, and then we can say, actually, I want to do for line in lines. Yeah, and here I can say if line dot is empty, then continue. Otherwise, we just need to read this from, so we can have an array of board lines. We can say board lines dot append line. If board lines dot count is equal to the board size, then we need to build the board here. And then we need to continue with board lines starting over. So we'll collect up to 5 of them. Then when we have all 5, we can build our board. And so then each one of these lines, board lines dot map, we'll take this string that we get, and we will split that with a separator of space, and then we will compact map that again to turn that into a string. I've done this so many times, I kind of want to make a util for it. So let's do an extension on int with a failable initializer that takes a s, which is a substring. And this just says self equals int string s. Can I do that? Wait, optional value must be wrapped. Oh, I can't do that. I need to say let if let int equals int, then self equals int, otherwise return nil. I actually like this better as guard let, else return nil, self equals int. Okay. Oh, great. I need to ban the spammers. Okay, where was I? So back over here, now I should be able to say compact map with int.init, and it should find that, which makes this just easier to read. Okay. Okay. So at this point, we have a bunch of numbers, and I want to flatten all of those numbers into a single array. And now I can create a board, bingo board, with the numbers of board numbers. And then boards.append board. Now that initializer doesn't work, but that's fine because we can create one. So this will be numbers is an array of int, and then we can say cells equals numbers.map to bingo cell.init, and cannot convert type of int bool. Oh yeah, I can't do this because there is no initializer that takes a single argument. The other one is defaulted, so we'll have to do it like this. Bingo cell $0, unless I make another. That's really dumb. If I add a curly brace, it just goes to the next one. That's really stupid. Oops. Leader SB, var boards, variable boards passed before being initialized. It's true. Okay. And now I can return boards. Okay, let's run it. And we've got a bunch of boards. It's very hard to read them. So let's print them out. Let's create a description method or debug description. Something like that I can print. Sure, why not? Okay. Do I know? Sorry, not on the cell. Well, I actually may want to do it on the cell also. But for the board, we'll do this. We need to know what our board size is here, because I don't want to do like the square root of that number. I'd rather just assert, once this is done, assert that cells.count is equal to board size times board size. So that way we can catch any issues where we don't have the right board size. And now I can say for row in 0 to less than board size. I'll just call it size. No, size equals board size. And this would be a good chance for us to also have columns. And then I could say, give me the index, I equals index for row and column. So we need to write that method anyway. So let's just say index for row int, column int, gives me an int. And this is going to be the row times our board size, times our size, plus our column. So at 0, we're just going to start at, you know, A, B, 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 B. Okay, where is that coming from? Super weird. Anyway, if this is our array, but it actually looks like this. So this is row 0, row 1, row 2. Then row times size at row 0 will start here, and then we'll add on the column. And at row 1 will start here. So the only thing we need to assert that row is less than our size, and column is less than our size. And we might as well do something like valid range is 0 to less than size. And then we can assert that valid range, I think it's this, includes row, and valid range includes column. Maybe it's the other way, tilde equals. Yeah. Let's make that unnamed. And then return. Okay. Here, now we have our index, and now I just need to print out this cell. Or I don't need to print it out. I need to append this cell's description. Cells I dot debug description. And then we need a separator, which maybe I'll just add a single space to the right. And then here we add, at the end of the row, we'll add a new line. And at the very end of the whole thing, we'll add another new line. And then return S. Plus equals. Okay, cells debug description. Here returns S. We could probably just do this inline. So this needs to be the value. And I think that maybe there's probably too much noise to add that. But I want to have some sort of indicator here that is, if we're marked, then we will use like that little dot character. Otherwise, it'll just be a blank space. So that way we can indicate if something is marked or not. And now here, board size is board size. Let's build, run. Okay, let's use our debug output. Debug description. Okay, I kind of want to do it like this. 4 board in boards. Print. Okay. 22, 13. Oh, and we have a problem with the alignment. So these are 2 digits, 2-digit numbers. Let's just double check our input, make sure there are no 3-digit numbers. Yeah, we're good. Okay. So we can use, for the value here, I can use a string with a format string. And this would be %02D. I think that's how I do it. Yeah. Okay, and now if I mark one of them, it'll have a little dot next to it. Okay. Running short on time, so hopefully we can get to this first challenge done today. So what do we need to do? We need to draw each one of the numbers and then mark the boards for which they appear. And so we have essentially a game that is running. So I think we want... I want to call this a bingo game. And this one takes in the numbers to draw and the boards. Now at this point, yeah, our bingo game parser can now return a bingo game. And numbers, boards, boards. Okay. Boards. What's wrong with that? Board. It can't find board. This is bingo board. Okay. Expected declaration. Bingo board. I think it just crashed. Yeah. One of the downsides of using a open source Vim, let's do this. Quit. Discard and quit. Something got messed up there. I'm not quite sure what it was. I am pretty confident it's actually the Syntactic plugin because that's the one that kind of causes it to hang a little bit. But okay, so yeah, so here I need a game now, and then now I have game.numbers and game.boards. Okay, and then the next problem still here. Can't find static func parse. Do I need a static func parse? Oh, there we go. Okay, so now we kind of want to run the game. And this is going to go through each number for number in numbers. And it's going to tell the board essentially to it's going to tell the board to receive that number, I guess, or evaluate the number. We could say, okay, so this will say we drew the number. And now for board and boards, each board should evaluate the number that was drawn. Now, at this point, it may want to mark one of those cells. So we could do this we could change the board to a class, and then change the bingo cell to a class as well. But one option would be to allow you to create new boards by evaluating. That would be more functional, more immutable. So this would be evaluating a number, and this would return a new board. And in that case, we would have a private init that has cells, bingo cell, which sets self dot and size. This would set self.cells equals cells, self.size equals size. And then here we would say create a new board where the cells are my cells mapping to a new bingo cell for this cell's number. Is that what I called it? Number? I called it value. And then is marked becomes if that $0.value equals the number we just drew. So now we have creating a brand new board that this can be self, and this can be bingo cell. Okay. Bingo cell. I need size. No, I don't need that. Okay. So at this point now, every time we do this, we get new boards. So it's like we start off with these boards, but now we'll have new boards every time. I'm not sure how I like that. I like the fact that you can basically keep the history of the entire game for each number. But if I say board evaluating number, now I've got a new board, and I need to put that back in this array. So this would have to be mutable, and this would have to be a mutating func. And then I would have to have an enumerated method so that I could get the index. And we could say boards at that index equals this. Okay, so after evaluating this, now we drew the number, we could evaluate this. This would allow each new board. I do think I want this to have new board so I can query it and that sort of thing. New board. And let's print the new board's debug description. And so then in our game, when we're running, We parse. Those are our numbers. We've got our game, and we can say game.run. And that means this needs to be a var. Okay, so we drew the number 7. So we can see that this one has the number 7. This one has the number 7. It's actually kind of hard to see because there's a space after this. I think that let's delete that space there. Okay, yeah, now it's a lot easier to see. So that's got a 7, a 7, a 7. Okay, and then we drew the number 4. Here's the 4. But the 7 is no longer marked. What happened there? Did I not update the array properly? Second time we ran through the numbers. Yeah. In our evaluating function, we're only checking all cells. So we're going to say, let me make this a C, just to make that a little easier. And isMarked is going to be C.isMarked, or C's value is this number. That way we maintain that it was marked the last time. So now we've got 7. Now we've got 4 and 7. And eventually we should get a winner. Okay. Running short on time. Let's see if we can get a winner out of this. So we need to check to see if a board is a winner. And so here we can say is a winner. And this one we'll need to check all rows and then check all columns. So for each row, we can say map this to the cells at the index for the row and column. So $0 is going to be the row here, and the column in this case is going to be, let's see, do we need to iterate twice here? I think we do. Yeah, so this is going to be row in, column in. How do I want to do that? I can actually return early if we're just enumerating. For row in 0 to less than size. For call in 0 to less than size. Yeah, I'm going to do that. So at this point we have... I don't think we need to iterate like that. We can say 0 to less than size dot map to the cells at index for row and column. So now we've mapped to all the cells in this row, and now we can say all satisfy, right? That's a function. All satisfy a predicate, and we just need to say is marked. Okay, so then we do the same thing, but this time we're doing columns. For call in size, and this becomes, sorry, that needs to be call. Let's just do $0 here. And so this one becomes row. Okay. So this is going to return a Boolean. So if this one is true, it will return true here. Otherwise, if it finds one here, if this whole thing is true, then return true. And if it didn't get to the end, then it'll return false. Okay, so at some point we need to stop when we get a winner. So in our game, let's say before we print it, if the new board is a winner, then let's print some party. Yeah, we have a winner. And then let's see, we want to print it. I'll print it first, and we'll say we have a winner, and then we're going to return. So we're done processing any more at that point. Okay, we get all the way to the end, and we have a winner. So this one is the winner. 14, 21, 17, 24, 04. Let's go here. Finally, a 24 is drawn. 14, 21, 17, 24, and 4. That's the winner. So then the score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. So yeah, so now at this point, we need to print out the unmarked sum of that board. So let's let the sum be the new board. Filter out all cells. Let's see. Cells.filter, not $0 marked, and then get the out of that we can get the value of that cell, and sorry, that needs to be map value. And let's make this a little bit of a pipeline there. And then we can reduce this with the plus function to get the sum of all of those. Okay, sum is 188. Okay, so that works. Let's grab our real puzzle input. And that's not what I wanted to do. I hit Command Q. Okay. Day 4 is input. Command C. Let's go to resources, add day 4.input. Paste that. Oops. Paste that here. Save and quit on that. Okay, day 4. Let's change this to day 4.input. We'll run it. And our answer is 763. It's not the answer. Okay, so we have a problem here. Oh, wait. Sum of all unmarked numbers. Then multiply that number by the number that was just called. Oops. Yeah. So the number that was just called... We have a winner, unmarked sum. Let's see. The answer is, and we're going to take the number that was just called and multiply it by that sum. Helps to read the directions. Okay, 38,913. Copy. have 9 seconds left to wait. Wow. I didn't know they did that. I guess built-in coffee break. Also realized that the chat window is on top of my head. I need to fix that. There. Much better. Okay. Okay, that's the right answer. You're 1 gold star closer to finding the sleigh keys. Okay, so, okay. Check, check, check. Let's go to our project folder, Advent of Code. We are working on day 4, part 2 today. Let's open up our Vim setup. Increase the font size a little bit. As a reminder, this is Advent of Code 2021, and we are working through these code challenges. We are essentially just doing just enough to get the challenge to pass and not worrying too much about super code quality or performance unless that is part of the requirement. Also future-proofing and trying to come up with a design sometimes may not pan out the way you want. And the idea is that, like in this one, part 2 gives us some other requirement. So it may change how we've done it. So we did part 1 yesterday. So let's work on part 2. Let me open up the day 4 file. And we will look at day 4's test. And let me just do a quick build and a quick run. And we get our answer. So this one will find the winning board, find the unmarked numbers on that board, and multiply it by the number that just won. So let's read the description for part 2. And while I'm doing this, if there are any questions on my setup or anything outside of that, feel free to drop a message in the chat and I will try to answer it. Okay. I should probably mention on Twitter that we are live. I definitely need to automate this. Okay. Part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148 for a final score of 148 times 13 is 1924. So we need to figure out which board will win last. Once it wins, what would its final score be? So if we go to our solution, right now we're running through, when we run our bingo game, we're going through every number. And then if we have a winner, then we're returning the fact, we're doing our calculation here. I think that we probably want to maybe extract this out so that the logic of processing through all of the boards and deciding if they won is part of the function. And then what to do with that data is sort of outsourced. So we will say maybe process number, something like that. And this will give us some sort of info about if a board won and which one did. Should we do it that way? Process, this returns the winning board. We could do that. And if we do that, then we can go this way. And then here, if a new board is a winner, we still need to keep playing, though. That's the problem. So I think this is kind of the wrong level of abstraction. Let me open something up real quick. we go. Okay. So one option would be to take a board, decide if it is a winner, and just continue on. Let's say, we could say, let's say we had some sort of win info struct, which is a board that won, and then the number that it won on, winning number. Something like this. And then okay, so I'm going to get rid of this function for now. And so this win info, what we're going to do is we're going to go through each one of the boards, and then we will create wins as an array of win info, which is empty. We will continue. And I also, okay, so once we evaluate the number, we update the board in our local array. If the new board is a winner, then we need to create a wins.append, init a new value where it has the board is the new board that we just created, and the winning number is number. Okay, so I'm going to get rid of this code for now. I'll just comment it out, and we don't want to return. So at the end, we have a bunch of wins, and we decide what we want to do with it. So our initial logic could be just to say to take this out of the first winning board. Yeah, let's do that. So this will get wins.first. Well, this is assuming that we have any. If let win, first win, equals wins.first, then we will move this stuff up here. And then we will grab the first win.board.cells, and then the number that they won is the first win.winning number. Okay. So at this point, we're still processing all wins, and we're just grabbing the first one. So let me run it. And at some point, we should have a winner. I think it was after the number 24, if I remember correctly. 24? No? Oh, here we go. We have a winner. Now we drew the number 10. We have a winner. We have a winner. We have a winner. We have a winner. I think that we need to stop checking. If a board wins, we need to stop checking. Yeah, because it's every single one is a winner. So the unmarked sum is 188 and then times the winning number. Was that the correct answer over here? 180 times 24 is 4512. Yeah, so everything is still working, but this will also mean that we have too many wins in this array. So we need to update the, we either need to update our board, which is probably is finished maybe. And that will be false. And then when you check winner is winner, it will mark it as finished. So we'll say we have a winner, new board dot is finished is equal to true. I want to move the saving of that board because again, it's a struct. We just mutated it. We want to save the correct version. And then now we can say if board, let's see, if board dot is finished, continue. So we'll move on to the next next results in the for loop. So we'll skip over any boards that are already finished. Okay, new board is a let constant. Okay, everything else is good. It is interesting that we continue. So not all the boards win, I guess. So we just need to know, after processing all of the numbers, we need to know what was the last one. So we're going to change our requirement to last win is wins.last. And at this point, I think it should work. See, winning number, last win.winning number. Okay, 1924 is correct. So let's move back over to our day 4 input, and we will run this one. And our answer is 16,836. Okay, let's go. So that's day 4 done.